Okay, so we're going to talk about radicals. So I want to kind of point out what's going on with those. So the part that looks like the check mark, that is the radical sign. The number inside of the radical is called the radicand, and the number outside the radical, where that n is called the index. So if n, that index, is an even positive integer, so if we're taking the square root of it, we're going to get a positive value. That's what those absolute value bars mean. And if n is an odd positive, then it's just going to be a. So if you're taking the nth root of something to the nth power, it's going to be that number. The main thing you need to know is you can't take the even root of a negative number, but you can take the odd root of a negative number. So 5 squared is equal to 25, but so is negative 5 squared is also 25. If I take the square root of 25, we usually just, in the course that we're doing, it would just be 5. When you get into further algebra, you might look at it, if you introduce a radical, that's when we do the plus or minus. But if we're just taking the square root of something, we just look at the positive value. If there's a negative out front, we can take the square root of 25 is still 5, but because of the negative out front, it becomes negative 5. You can take the square root of 0, it equals 0, but we can't take the square root of negative 5 because there's no number times itself that gets you negative 25. You would have to have negative 5 times positive 5 to get you to negative 25, and that's not the same as a square root. Remember, the square root is something squared, something times itself, so that doesn't work. But you can take the cubed root of a negative number. That means you have 3 of them, so the cubed root of negative 27 is equal to negative 3 because I can multiply negative 3 times negative 3 times negative 3 and get to negative 27. We aren't going to get too technical in that here. We are going to just use our calculators to take the square root. We'll probably just deal with square roots in this course. So let's look at example 1. So for example 1, we're going to take the square root of 65. If you've taken algebra, sometimes you're finding the exact value, but in this course, we are just finding the value, the decimal approximation. So I'm going to plug it into my calculator and take the square root of 65. On mine, it gives me the exact value if I use the double arrow. It gives me my decimal. We're going to do all of these to 2 decimal places. So I would write 8.06. Okay? And that's your answer. All right, let's look at example 2. We want to take the square root of 2,756.9. So second square root, because my square root is a green, so I have to push the second button. And then I type in 2756.9 and hit enter. I want to go to 2 decimal places, so it's 52.50. The 6 that is on the right side of the 0 is 5 or greater, so that makes me round up my 0 to a 1. So this will be 52.51 as my answer. All right, let's go to example 3. This is the square root of 83. So second square root, 83. And that will get me 9.11 because the 0 after it will not cause it to round up. All right, let's step it up just a little bit. Let's look at example 4. So for example 4, we are given that the square root is 16 divided by 2. So we have to do some math before we take the square root. The 16 divided by 2 will reduce to the square root of 8 because 16 divided by 2 is 8. And then second square root of 8. Now my calculator is going to, because this is what it does, it gives me the exact value, but I'm looking for decimal approximation, so again, I'm going to hit on this calculator, this double arrow, to get my decimal. So it's 2.8 And what happens to my second number? Well, the number after the 2 is another 8. That's 5 or greater, so it will round the 2 up to a 3. All right, let's look at example 5. We're looking at the square root of 75 divided by 3. Well, 75 divided by 3 will get us 25. So we're looking at the square root of 25. And the square root of 25 is in our example that we started with on the pink paper. And the square root of 25 will be 5. It's 5 times 5. If you don't know, you can easily pop it in there, and you'll get your 5 that way. All right, let's look at example 6. So example 6, we have the square root of 42 divided by 4. And when you write those square roots, if you get them a little short, just draw a line a little bit further down so that you know it's all under it. Well, 42 divided by 4 is 10.5. So now we're looking at the square root of 10.5. Second square root of 10.5 will get us 3.24. The 0 after the 4 tells us we will not round up. We'll just leave it at 3.24. All right, let's look at example 7. So for example 7, we are looking at the square root of 16 plus 14 divided by 4 minus 1. So it looks a little short, so I'm just going to extend my line a little bit. You want to make sure it's all under it. So I'm going to add the top first, which gets me 16 plus 14 is 30, divided by 4 minus 1 is 3. Well, 30 divided by 3 is the square root of 10, and the square root of 10 will get us 3.16 in our calculator. All right, our next example, example 8, we have the square root of 14 minus 5 squared over 5 minus 2. Well, we have to follow our PEMDAS rules, so 14 minus 5 will get us 9 squared, divided by 5 minus 2 is 3, and that's all underneath a radical. So 9 squared will get us 81 divided by 3 still. And 81 divided by 3 would be the square root of 27. If we put that in our calculator, we will get 5.20 because we'll need to round up. So let's look at that one. Second square root of 27, we get 5.196. Well, that 6 causes the 9 to become 10, which gets us a 0. The 1 carries over, and we end up with 2. So be careful about those when they end in those 9s where they round up. All right, let's look at example 9. So we're looking at the square root of 13 plus 12 plus 5 plus 9 divided by 7 minus 3. So that'll give us the square root. 13 plus 12 plus 5 plus 9 is 37. 7 minus 3 is 4. And that gets us the square root of 9.25. And when we plug that in our calculator, we will get 3.04. All right, example 10 has a little bit more to it, so we're going to change to a new sheet of paper. So for example 10, we're given a data set. And we are given 5, 9, 7, 11, 4, and 6. So we're looking at the summation of x minus 2 underneath 6 minus 1. So You're going to find the summation like we've done before, and that means you're going to plug in each of your data values into it. Then we're going to divide by this, and that's all under the radical. If you are in contemporary math or stats as well, this is going to be similar to the standard deviation formula. Not exactly, but we're working our way towards that. So you really need to understand that. All right, so I've got to find the summation. And I've got to plug all of these in there. So we're looking at 5 minus 2 plus 9 minus 2 plus 7 minus 2 plus 11 minus 2 plus 4 minus 2 plus 6 minus 2 all over 6 minus 1 is 5, and I'm putting on my radical last because I got to see how long it needs to be. And that's all under the radical. All right, so 5 minus 2 is 3. 9 minus 2 is 7. 7 minus 2 is 5. 11 minus 2 is 9. 4 minus 2 is 2. 6 minus 2 is 4. All over 5 and underneath the radical. You only write the 5 one time under all of them, not individually. Remember, this sigma is summation. You add all of the values and it's all under one radical. All right, so if I add 3 plus 7 plus 5 plus 9 plus 2 plus 4, I end up with 30 divided by 5, which gets us the square root of 6, because 30 divided by 5 is 6. And if we put in the square root of 6, we end up with 2.449. Well, that 9 tells me my, whoops, you can't see because of the lights. 2.449, that 9 tells me that my 4 will round up to a 5. So it will be 2.45.